This is section 2.7, and we're going to be studying linear inequalities in this section. Up until now, whenever you've looked at an equation, we've always had an equation or equality with an equal sign between the two sides. An inequality is simply a mathematical statement that uses either a less than, a greater than, a less than or equal to, or a greater than or equal to sign between the two sides. Solving linear inequalities really comes down to remembering kind of one special rule. Essentially, you can solve them using the normal same steps that you normally would to solve a linear equation, except if you multiply or divide both sides of an inequality by a negative number, you have to reverse the inequality symbol. So less than becomes greater than, or less than or equal to becomes greater than or equal to, and vice versa. All right, we're going to practice this a couple of times, and then we're also going to take a look at graphically how we can kind of connect what we see in our inequality solutions with things that we know about the graphs of some of this stuff. So my first inequality, 2x minus 9 is less than 5. All right, well, normally I would add 9 to both sides, and that's no problem. I can do that. And then to get x by itself, I would usually divide by 2. And I'm not dividing by a negative number, I'm dividing by a positive, so don't have to do anything special. I just end up with x is less than 7. That is my solution to my inequality. X can be any number that's smaller than 7. Now notice it says express your answer in interval notation and also graph it on a number line. I'm actually going to do the number line graph first. And this doesn't have to be fancy. I'm just going to go ahead and put my 7 on there. And I'm going to say x's are not equal to 7, so I'm going to put an open circle. But I want the x's to be smaller than 7. So this would go from negative infinity to 7. Remember, always read your intervals from left to right, no matter which way the arrow points. So 2x minus 9 is less than 5 for all x values less than 7. I'd like to connect that to a graph on Desmos. I'm going to graph the linear equation, y equals 2x minus 9. And actually, I'm going to change my window just a little bit here. There it is. Notice the slope positive 2, and notice the y-intercept negative 9, just like we would expect, right? All right. The question was, when is this value less than 5, right? The inequality said less than 5. If I just add the y equal 5 line to my graph, the intersection point right here is 7, 5. And notice that my 2x minus 9 line is smaller. It's less than 5. Up until I get to 7. So for all x values up until 7, 2x minus 9 is less than 5. That's exactly the solution that I came up with algebraically right there. All right, let's try another one. 6 is greater than negative 4x plus 14. So let's see, I'm going to start by subtracting 14. Negative 8 is greater than negative 4x. Notice I was just subtracting, not multiplying or dividing, so I didn't change my inequality. But here is going to be the first place I'll have to worry about that rule. To get x by itself, I have to divide by a negative 4. And because I am dividing by a negative number, in my next line, dividing here gives me 2. and I have to reverse this inequality. The greater than sign becomes a less than sign. And then I have my x. So 2 is less than x. If I were to draw a number line graph of that solution, I'm just going to put 2 on it with an open circle because it's just less than, not less than or equal to. Which way should my arrow go? X is actually larger than 2, right? 2 is smaller than x, so x is larger than 2. I want all the x's that are bigger than 2. Sometimes people get confused when the x lands on the other side, and I would recommend that if you don't like that, if that tends to cause you confusion, you can rewrite this inequality with x on the left. Just make sure, right, the big side of the sign is pointing at x, the big side is pointing at x, little side's pointing at 2, little side's pointing at 2, right? Those two statements are identical. They mean exactly the same thing. But for a lot of people, reading this as x is greater than 2 makes more sense when they start thinking about the number line graph. In terms of interval notation, x goes from 2 to infinity. All right, let's try this one out on Desmos. Let's see here. My line was y equals negative 4x plus 14. There it is. Notice that negative slope. Looks good. And then I'm also going to add y equals 6, which was the other side. Right. And if you remember, let me go back to this. I actually wanted the 6 to be bigger than that slanted line. So over here, 6 is on top of or larger than the line from 2 on, right? When x is 2, 3, 4, 5, etc., whenever x is bigger than 2, the 6 is actually bigger than that line. That's exactly what we came up with. X is larger than 2 or from 2 to infinity. All right, I've got one more just kind of straightforward example before we get into a couple of applications. I need to first of all just solve this algebraically, and again I'm just going to start by doing what I would normally do in any linear equation, which is I'd probably want to start by distributing that 3. All right, I'm going to get the x's on the same side, and if you tend to like the x on the left, and my experience is most people prefer that, then you might want to subtract the 8x. That way all your x's end up on the left-hand side. So I have negative 5x minus 12 is less than or equal to negative 2. I'm going to add 12. Sorry, computer's behaving a little strangely. There we go. I'm going to add 12 to both sides. Negative 5x is less than or equal to 10. And here we go again, right? I now have to divide by a negative number. And because I'm dividing by a negative number, I'm going to reverse my inequality. So x is greater than or equal to negative 2. All right, so first of all, this time I'm going to put a solid dot on the negative 2 because it's not just greater than. It's greater than or equal to. And I want greater than, so I'm going to go this way. My interval would go from negative 2 to infinity, and notice I'm using the bracket this time, to include the negative 2. All right, how could we see this one on a graph? What I'm going to do is I'm actually going to say this time, instead of one side being a constant, I have two lines with slanted slopes, one on each side. So I'm just going to graph them both. The one on the left was 3 times, oops, let's do y equals 3 times x minus 4. And the one on the right, I'm going to do y equals again, 8x minus 2. Here they are. Notice there's that negative 2 where they intersect, right? I got negative 2 as part of my answer as well. But how do I know whether it's the x's smaller than negative 2 or bigger than negative 2 based on the graph? Well, if you remember back here, we wanted the first one to be less than or equal to the second. So the first one's supposed to be smaller than the second. On my graph, that means I want the green to be smaller than the blue. That's true over here, right? Green is smaller than blue. Once I get past negative 2, once I get bigger than negative 2. So from negative 2 on out to infinity, that will be true. All right, we're going to finish this section with a couple of applications. A little bit ago, we did that example about the yogurt sales, and we found an equation like this, right? We already found the equation, so we won't do it again, but we actually did this one from the data when we did this problem before. Yogurt sales in billions of dollars was n of t equals 0.19 t plus 2.09, t representing the number of years after 2000. We are now supposed to write and solve an inequality to find out what years the model predicts our yogurt sales to be over $5 billion. So we want our yogurt sales, n of t, to be over, greater than, $5 billion, but the model was in billions, so I can just say 5. Or in other words, 0.19 t plus 2.09, which is simply the function for n of t, has to be greater than 5. All right, let's solve this. I'm going to subtract 2.09. So 0.19 t is greater than 2.91. And then I have to divide by 0.19. Notice I'm dividing by a positive number this time. So I do not have to reverse my inequality. I just need 2.91 divided by 0.19. And I get t is greater than 15.3. So let's see. T was years after 2000. So this would be after, right? Because it's greater than 2015. All right, let's try one last problem here in this section. We have a set of data here. For various years, it tells us what percent of new cars sold had a manual transmission. So you can see from 2010 to 2020, the popularity of a manual transmission seems to be declining. People want automatic transmissions, apparently. Most people do. All right. T is supposed to be years after 2010. So put my T's out here. 2010 is 0, and I would have 2, 4, 6, 8, and 10 years later. And first of all, we probably need to come up with a model. We're hoping this is going to be linear. It's the only modeling type we have so far. So we'll go ahead and put this data on a graph. verify that a linear model is appropriate, and let's start by just getting a linear model for that data. And then we can go on and answer that question. All right, so back in 2010, 6.2% had manual transmissions, and then we're going down from there. And I'll fit. All right, not a perfect straight line. Obviously, we had a little jiggle in it here, but I could certainly see a line could come close to those points. So I believe that a linear function is a reasonable model here. We'll do our linear model, y1 tilde, and then mx1 plus b. And there we go. All right, so first of all, visually I can see that the line is pretty close to the data points. R squared is 0.97, that's pretty good. Reasonable model. I'm going to keep 2 decimal points, I think. So I'm going to call my slope negative 0.29. And for the y-intercept, for the b, I'm going to go with 5.99. So I just jotted that information down here. And that means that, let's see, t was my time. Let's go with m for manual transmissions. I'd have m of t equaling negative 0.29 t plus 5.99. All right, so now I'm ready to answer the question. When does this model predict that less than 1% of new cars are going to have manual transmissions? So I want this m to be less than 1. All right, let's solve it. I have to subtract the 5.99. So negative 0.29t is less than 4.99. By the way, I wrote my function in function notation, but you'll notice that when I'm solving the equation, I'm just kind of ignoring that, right? I'm just working with the inequality now. And then I need to divide by negative 0.29. Now I did divide by a negative number, so I have to reverse my inequality. T is going to be greater than, and grab my calculator here real quick. Uh, 17.2 when I divide those. All right, so the starting year was 2010, 17 years later, and t is bigger than that, so after, what would that be, 2027? We're predicting less than 1% of new cars would have manual transmissions. All right, kind of a short little section there. That brings us to the end, and we'll finish up the chapter, the unit, with 2.8 next time.